antimatter. When you hear me say that, you're probably thinking of some unobtainium-esque sci-fi material. And in fact, it is. It's what powered the USS Enterprise, even. However, it's also something more than that. It's a real thing. It's a real material with real properties and even some real mysteries. The concept of antimatter was first proposed after some careful examination of the equations for quantum mechanics. Quantum mechanics is the theory that describes how super tiny stuff, like atoms and subatomic particles, behave. And quantum mechanics is very inherently probabilistic. That means that instead of describing a particle as having a certain defined position and momentum and a whole set of states, quantum mechanics says that a particle has a certain chance of being in any set of positions. Because of this, we can represent particles not as just a particle, but as a wave corresponding to their probability of being at any particular location. Quantum mechanics isn't limited to just these positive probability waves. You can actually have a negative probability for a particle. So take, for example, an electron. If you look at the probability that it's in a certain spot, it'll look something like that, where it's very likely that it's in this small area, and very unlikely that it's somewhere else. However, if you put a negative dip into the graph, there's a negative probability that an electron will be there, which sounds completely insane. It doesn't sound like it should work, but it actually does, and it creates what's called antimatter. An anti-electron, in this case, would have the exact same mass and most of the same properties as an electron, except it would have the exact negative electrical charge. So an electron has a charge of -1, and an anti-electron, also known as a positron, has a charge of +1. But there's also a very fundamental mystery to antimatter. If you've heard anything about Albert Einstein, you've heard his famous equation E = mc². And that just relates energy to mass, which means that energy can be converted into mass. And this actually happened at the very beginnings of our universe, in the Big Bang. The Big Bang had a whole bunch of energy, and it just converted it all into mass. However, when energy is changed into mass, it creates an equal amount of matter and antimatter. Our best experiments so far have shown that it's a perfectly equal amount of matter and antimatter. There's no offset at all. However, when we observe the universe, the only thing we see is matter. Even though we know that energy must have created all the matter in our universe, and so should have made an equal amount of antimatter, we haven't seen any antimatter. Everything. My book, this water bottle, this pencil, it's all matter. There's no antimatter anywhere, except in some of our best particle accelerators. In fact, at CERN, there's a place called the Antimatter Factory, which works on making anti-atoms, which is super cool, but there's no antimatter anywhere to be found. We've looked at the deepest depths of the universe and haven't found a trace of it. And I guess that's just one of the deep mysteries of our universe that's yet to be figured out by either physics or astronomy. Thanks for watching.